Hi, today we're going to be talking about the language of functions. Now that sounds pretty, honestly pretentious, but we'll get through it. It's really not as complicated as the title might imply. Really, it's just talking about how to read graphs and understand data sets and write out functions. It's really just translating English to math and math to English. So this is asking us how long the football traveled in the air. Use the given graph to answer. Now we have time on the bottom, it tells us this, and we have height on the y-axis. So we want to know how long until it hit 0. So we basically want to know our x-axis. And our answer for that is 4. It's pretty simple. How long did the football travel in the air? Same kind of question. 3.2 seconds. This one is asking us to put the function together in math language. So we know that an unlimited ride pass is $22. That price doesn't change. You buy one unlimited ride pass and you don't have to pay that $22 again. We have $1.50 per game. How many games you pay will affect the cost. So let's tag an X to it. We want to know, we want a function that represents the total amount we spend on rides and games at the fair. So we already know that there's going to be a plus 22 here because that doesn't change, plus $22. And we know that we have a 1.50 X. And this here is telling us to indicate domain restrictions. Now, when we're talking about range and domain, we're basically saying what are the limits of our graph? Domain deals with the x-axis, and range deals with the y-axis. Now, in our carnival example, you cannot buy negative games. You cannot play negative games. You will not get money for going backwards with the amount of games that you play because that doesn't exist. So we know that we cannot have any values that are negative here. We have to stay in this first quadrant. And it'll look like that. So X has got to be greater than or equal to 0 because you can play 0 games. That's allowed. You are allowed to play 0 games. We'll deal with that in the last problem. So I believe, yeah. This one is asking us to complete the table by evaluating the function h of x is equal to 2 of x minus 2 squared for the given values of x. This one, we're simply just plugging in what we have. We need to plug in negative 2, so we're asking for this negative 2 value, the 0 value, and this 2 value. And I'll do the first one. So 2 times negative 2 minus 2 to the second power. We need to do what's in the parentheses first. So 2 times negative 2, and then we need to do the multiplication first. So that's going to give us negative 4 minus 2, which is going to give us negative 6. Negative 6 squared is the same as positive 36. So we'll add that in there. 0 would, well, I think that you guys could do the rest on your own. But basically, we're just plugging in values. We're doing basic algebra. I thought the last one dealt with a more hard domain restriction. I don't think it does. So if you have a problem that has and then x, and then bloop, and then you basically put in your value here. X has to be greater than or equal to, or maybe it's just greater than, or maybe it's less than or equal to, or just less than, and then a value or whatever. I don't know what it would be in this specific example. We know that x has to be greater than or equal to 0 though. And if you remember these signs, the alligator always wants to eat the biggest thing, right? So if you have 0 on one side and 2 on the other, the alligator is always going to face the 2. If you have 2 on this side and 0 on the other, the alligator is going to face the 2 because it's hungry and it doesn't want the 0. So this one is telling us to graph the given equation by evaluating integer values of x from -2 to 2 and plotting the resulting points. Now we already know what the y-intercept is. It's going to be +1. It already gives us that. You could make a table and plug in like 1 for 2, 1 for x, and then find what y is. But I like just graphing it with what we have already. So we know that our slope is -3/2. So you go down 3/2. And you have to keep in mind that the graph sometimes is not going by what you expect. I just almost did this right here, but actually -3 would be right here. So down 3/2. And then up 3. So 1, 2, 3/2. So that gives us these points. But it's a little trickier when it is in the middle. At that point, I would just plug in the values. I don't like that Hawks makes it so you have to do the first two, to -2 to +2. But it is what it is. So that's what I would do. You can find the others by plugging in, say, -1 for x and 1 for x. Yeah. If you have any questions, please let me know, and I'll answer them as soon as possible.